हेलो, आप सभी लोगों का स्वागत है इन इंडिया लर्निंग सेंटर। वी विल कंटिन्यू फ्रॉम द लास्ट टॉपिक which is exercise on electric charges and fields. NCERT, we will follow from the NCERT book. Now the question number 1.11. In these questions, the polythene, it is asked a polythene piece rubbed with wool is found to have a negative charges of itna itna. So first question, estimate the number of electron transfers from which and which. So we have now in this question, say if I rubbed polythene, polythene is rubbed rubbed with wool. So here when we rubbed these two, polythene and polythene with the wool, some electrons are transferred from wool to the polythenes. So these electrons, since when you rubbing two object, there is some friction between the surfaces of these two, polythene and wools. Therefore some electron, due to the frictions, we are doing some work, and this energy is given to the electrons of the wools, and these electrons coming out the orbits of the atoms and goes in the polythene. Therefore negative charge transferred, we say that negative charge transfers from wool to the polythene. Negative charge means electrons. Negative charges is transferred from wool to the polythene. So next question is how much negative charge transfers from wool to the polythene. So this is the charge which is transferred from wool to the polythene. We need in this part, in first part, we need the number of electron transfers from wool to the polythene. This is the formula. Q is equal to Ne, either charge on the electrons, and it belong to the set of integer. So now we need N is equal to Q divided by E, and putting the value of Q, charge transfers from wool to the polythene, which is Q, and electronic charge on the electron is minus 19. If you solve this one, 30 10 की power minus 7 plus 19 divided by 16. Now this value comes out approximately 16 1 just 16 decimal approximately 1.9 10 raised to the powers minus 7 plus 9 is 11. 19 plus 12. So that much of electrons are transferred from wool to the polythene. Now second part, is there a transfer of mass from wool to polythene? Is there a transfer of? Yes, there is transfer of masses. Transfer of mass. We have given wool have given electron are transfer. Electrons are coming from here. So here when the electrons one electron transfers from the polythene. Electron has some masses. Electron goes this side, and electron has the mass. We know that mass of the electron is 9.110 raised to the power minus 31 kg, which is very small. But we say when an electron goes from wool to the polythene, So the mass of the electron also transferred to the polythene. So answer is yes. Yes, mass of the electrons also transferred from wool to polythene. From wool to the polythene. Now question number 1.12. In this question, two copper sphere. If I suppose a copper sphere placed at the point of A and B, both have given the charges 6.5 10 raised to the power minus 7. 6.5 on copper sphere B also. What is the Coulombic electrostatic repulsion? Distance between them is 50 centimeters. We need Coulombic repulsion between them. So Coulombic repulsion between them, this is the formula from the Coulombic law. 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught product of the charges Q1, Q2 divided by R square. So this is the formula. If I place the value here, F is equal to 1 upon 4 pi epsilon naught has value 9 into 10 raised to the power minus plus 9 and the product of the charge is 6.5 10 raised to the power minus 7. 6.5 into 10 raised to the power minus 7 whole square, and the distance between them is 50 centimeter. If you convert 50 centimeter into meter, it will be 0.5. 50 divided by 100, 0.5 whole square. Now if you simplify this one, so 9 square of 6.5 is 25 42. It means that 42.25 into a square of 10 raised to the power minus 7 will be minus 7 minus 7 minus 14, and in the denominators we have 0.5 whole square of 0.5 0.25 into yes, only 0.25. Square of 0.5 is this much. So remove the decimals from the numerator, denominator, it comes out 9. Two places of this one, 42 25 into 10 raised to the power minus 14 divided by 25. Now if you solve this one, divide 42 with 25, it comes out 9. 25 1 25, and remaining 15 17 172, 15 6 150, and again 150, 22 20 25, 25 9 225. This is the value of this one, minus 14 Newton. If you multiply it 9 into 169, the value comes out now. If you multiply 9 into 169, but there one term 10 to the power 9 is remaining here. 10 to the power 9 is also 9 into 10 raised to the power 9. So plus 9 is there also, plus 9. Now if you multiply 9 169 1521, to what remaining, minus 14 plus 9. Minus 14 plus 9 will be minus 5. Minus 5, and the decimal comes, if I play the decimal between 1 and 5 to standard format, 1.5 1.521 into 10 raised to the power minus 2 Newton. This is the value. So 1.5 to 1.52 and 10 raised to minus 2 Newton is the force between these two charged particles. Force would be repulsive forces because both are positive. This is positive, ये भी positive है, तो repulsive force would act between them. Now in second part, this is our first part. Second part of this question, it says that uh, what is the force of repulsion if each sphere is charged double the above amount and distance between them is halved? So in this question, if I give the charges twice of the earlier one, so earlier charges 6.5, twice of this was. Now the charges on each sphere Q1 and Q2, Q1 and Q2 will be twice of this one, 2 into 6.5, 10 raised to the power minus 7 coulomb, and the distance earlier is 50 centimeter. We have to half of this ones. Half of this means 50 divided by 2, 25 centimeter the distance between them. So now what will be the repulsive force between them? Now utilizing the same formula, F is equal to 1 upon 4 epsilon naught. This is our formula. 1 upon 4 pi epsilon naught product of the charges, that is Q1 Q2 upon R square. So now in this question, our value is a 1 upon, it's a 9, 10 raised to the power 9. The value of this one, product of the charges, which is this one, 2 into 6.5 will be 13. 2 into 6.5 raised to the power 10 raised to minus 7 whole square divided by square of r. Here r is 25 centimeter, it comes 0.25 meter हो जाएगा. Now 0.25 whole square of this one. So here put the numerical value one side and 10 raised to the power one place. Now it become 9. Now 2 into 6.5 become 13, square of 13. Square of 13, 169. And 10 minus 7 minus 14. And here 10 to the power 9 is also, power is added because base is same. And the denominator has the value squaring 0.25. We have just 25 into 25. 10 raised to minus 2 from प्रत्येक से आ जाएगा -25 and -25, 10 raised to minus 4. Now if you simplify this expression, so 9 into 169 into minus 14 and 9 is minus 5. Minus 5 minus 4 is coming from the denominator divided by 25 into 25. So now if you divide this one, so 9, 169, 10 raised to the minus 1 and 25 into 25. So now if you divide, the value will come out 0.25, 0.24 Newton. So in this question 0.24 Newtons, our force between these two spherical bodies increased. Earlier one approximately 1.5, this is the earlier value, 1.5, 10 raised to the minus 2 Newton. Now in this case 0.24. Now in this question, this very good question, two charge plate, one charge given positive, another is minus negative plates. So definitely there will be electric fields from positive plate to uniform electric field downward direction. So this is electric fields between the plate, that this will be uniform. Now here particle number one deflected towards this one, toward the positive plate, so it has a negative charge. Particle 2 also turn toward the positive plate, so it would also have negative charges, and this is the third particle. Third particle turns toward the negative plate, so it would have a positive charges. So now so here in this question, so it has the charges on number one beam, because all have passing through the between the electric fields, so they have experienced the same electric fields. Now first particles definitely will have a negative charge, minus q, and second particle number 2 also negative charge, and particle number 3 has a positive charge because it turns toward the negative plates. Now next we have to find out charge upon mass ratios. Suppose if they have the charges, each have the charges same one, charge by mass ratios. So we have charge divided by mass ratio, which particles would have the highest one. So this is our question. So make a x-axis, y-axis here. So this is our x-axis and this is our y-axis. So there is electric fields between the plates. So definitely there would be a force on this one. Now F is equal to charge into E, QE. If the mass of each particle is m, F is equal to QE and F is equal to ma from the Newton's second law, QE. Now therefore our acceleration which is acting between these particles, QE divided by m, this is our acceleration. Now using the formulas here, y is equal to, now s is equal to ut plus half at square. This is the formula we will use here. Ut plus half at square. If I take suppose s ut half at square, let us suppose initial velocity they have u is equal to 0 for our calculation point of view, and they deflection, they one or two deflecting upwards and third is deflecting downward directions. So here h is equal to u equal to 0 half, put the value of acceleration which is QE divided by m into time t square. T square, t will be the same, t will be time taken by each particles will be the same, because they experience the same forces in different directions. So for the positive charge, the forces, the positive charge, for the positive charge the force will be downward direction, for negative it will be upward direction. तो यहाँ पे नंबर 1 और 2 पे हमारे पास जो एक्सेलरेशन होगा ये अपवर्ड्स हो जाएगा, बिकॉज इन दैट केस acceleration means upward direction, the force will be F is equal to minus Q times of E. So if I put the value of yes, this is our value, force will be in upward direction, definitely acceleration also upward direction, the particle deflecting in upward direction. तो यहाँ से हमारा acceleration निकल जाएगा, we will get from here, and for the positive charges this acceleration is just negative of the electric field. Our electric field downward direction, acceleration upward direction for the particle number 1 and 2. Now for the particle number 3 हमारे पास acceleration downwards हो जाएगा. For the particle number 3 our acceleration will be, because charge is q is positive, therefore your acceleration for the particle number 3, तो ये would be on the third particle. तो ये क्या होगा हमारे पास, in the direction of A और E in the same direction, downward direction, यानी कि हमारे पास फोर्स डाउनवर्ड डायरेक्शन है, एक्सेलरेशन भी इस पे डाउनवर्ड डायरेक्शन लगेगा. So now this is our expression, h is equal to deflected by the particles 1, 2 and 3. Now half QE upon m into t square into t square. So since forces on the particle are the same ones, they are moving, all three particles going from the mid place. This is the mid region of this between the charge plate. So they so that's why the time taken to reach the end. तो यहाँ से यहाँ तक का जो टाइमिंग हुआ इस पार्टिकल का विल बी द सेम वन, बिकॉज तो यहाँ पे फोर्स बिटवीन द चार्जेस आर द सेम. फोर्स force acting on the charge will be the same. So here H is equal to QE twice m T square, ये हमारा वैल्यू हो जाएगा. दिस इज डिफ्लेक्टिंग वन हाफ Q. तो यहाँ पे हमारे पास E T स्क्वायर इज द सेम वन. तो इलेक्ट्रिक फील्ड हो गया टाइम and half will be the same one, therefore H directly proportional to E by m. So हमको चाहिए था not E by m, E the same one, we need Q by m. Q by m, charge mass ratio is required. So this is required, which particles have the highest one. So here looking from here, particle number 3 deflecting downward directions, सबसे ज्यादा नीचे की तरफ आया हुआ. ठीक है, पार्टिकल नंबर 3, आफ्टर दैट 1 देन 2. सो लीस्ट वन इज पार्टिकल नंबर 2. तो इसका डिफ्लेक्शन डाउनवर्ड डायरेक्शन इज हाईएस्ट. So it is deflecting toward downward direction is highest. So the particle number, our answer is particles. Particle 3 deflected highest. So deflected highest, so it's a charge upon mass ratio is also highest. So Q by m will be more. Will be more for it.